Hello everyone, my name is Scott Hodgdon and I am a Senior Technical Marketing Engineer in the Enterprise Networking and Cloud Group in Cisco Systems. In the Cisco SD-Access channel, we share with you features and technologies of the Cisco SD-Access solution and show you how to enable them. Cisco SD-Access is a crucial part of Cisco's Zero Trust solution, providing automated, dynamic, multi-tier segmentation for user, device, and application traffic. Cisco SD-Access automates user policy so organizations can ensure the appropriate access control and application experience are set for any user or device to any application, user, or device across the network. This is accomplished with a single network fabric across LAN and WLAN, which creates a consistent user experience anywhere without compromising on security. Today I'm going to talk about the IP-directed broadcast capability introduced in SD-Access version 2.1.2. The first thing I usually ask myself when looking at something new is, why was this new capability introduced? One of the main drivers for the development of the SD-Access IP-directed broadcast capability is the need for customers to use Wake on LAN services to install software updates on devices, usually during off hours. The challenge with Wake on LAN and SD-Access is that the Wake on LAN server often sits outside the fabric site and services different subnets, as shown here. You can see, for example, that the Wake on LAN server is in 10.110/24, but the hosts are in 10.120/24. Silent hosts are those that do not respond to normal keep-alive mechanisms and that only speak when spoken to on the network. They are often IoT devices that have minimal and in some cases very unique IP stacks. Silent hosts pose a challenge in the SD-Access environment due to the fact that the forwarding information in Lisp relies on hosts to be somewhat chatty or at least easily kept awake by keep-alive mechanisms. As a result, customers need a way to keep these devices active, and one such way is to use a subnet-directed broadcast from a source in the data center outside the fabric site. Just as with Wake on LAN, these sources are often servicing different subnets. In the example shown here, the server has an IP address of 10.10.10.30, but it is sending a directed broadcast to 172.16.120.255, which should hit all devices in the 172.16.120.0/24 subnet in the fabric. As part of DHCP operations, there is a loopback on the border for each IP subnet's Anycast gateway present in the fabric site. DNA Center replaces this loopback with an SVI which supports both DHCP and IP-directed broadcast capabilities. The two key pieces of configuration on this SVI are the No Auto State and IP-directed broadcast commands. No auto state keeps the SVI active even if there are no physical ports using the VLAN for that SVI. IP-directed broadcast enables the border to convert the packet from the server into an Ethernet broadcast for the VLAN that is using the SVI. When the edge node receives the frame, it forwards the packet as a broadcast to the endpoints in the destination VLAN. There are two critical requirements for SD-Access IP-directed broadcast. All fabric edge nodes and border nodes must be Catalyst 9000 series switches. Also, multicast must be enabled in the underlay, as IP-directed broadcast requires a Layer 2 overlay in the fabric site. Now, let's have a look at how IP-directed broadcast is enabled. Now that we've seen an overview of the IP-directed broadcast feature, let's see how this is enabled for both existing and new subnets that might be in a virtual network. So first we're going to go here and take a look at our site. So we'll do provision, we'll do fabric sites, and we'll come to this site SD-02. And if we go to host onboarding, we can see that we have a virtual network in this site called Corp. If we hover over this, it'll say it's got one host pool. If we click on this, we can see that there's a Corp VLAN here with 172.16.21.0/24. I just know that the default gateway is .1. The VLAN's been assigned as 200. And notice here that IP-directed broadcast is disabled. Now we can go back here to the infrastructure and do a quick look to see the before and after of what happens when I go ahead and enable IP-directed broadcast. So first we're going to look on the border. Now remember, during the presentation portion I said that on every border there's a loopback that's built that has the same IP address as the default gateway, the Anycast gateway on the edge node, and this is to facilitate DHCP communication. So if we do a little command here of show run interface L0200, we'll notice that again I've got 172.16.21.1. This is the default gateway for that subnet. It's in that it's got the same number as the VLAN that we saw. It's actually in the VRF corp that we set up, because remember, a VN in DNA Center terms is a VRF in iOS terms. So we can see we have this loopback as I previously described. And if we exit out of here and go and look at the edge node and do the same command here, but not for loopback, but just for an SVI, so we can do show run int VLAN, oops, almost typo there, 200. We'll notice that I've got this same IP address here, right? And I've got a bunch of other configuration as well, but I'm in the VRF forwarding of corp. I've got my Anycast gateway helper address pointing to DHCP, etc., and a few other commands that we put there by default. Don't have to worry about those right now. So let's go back into our host onboarding, and let's go to that network of corp, and let's enable IP-directed broadcast. So to do that, I just select it, I come to action, I hover over action here, and I can say enable, disable IP-directed broadcast. Now, there's two things that are going to happen here, and I want to point it out ahead of time. Notice that both IP-directed broadcast and layer 2 flooding are disabled on the screen. And as soon as I say enable, notice that they both went enabled, because remember, IP-directed broadcast requires layer 2 flooding to be enabled. So we make sure that this is enabled by enabling the layer 2 flooding as soon as we change this from disabled to enabled. Now also remember that layer 2 flooding requires multicast in the underlay. I have not enabled that here, to be fair, but in a network, if you want layer 2 flooding to work, you're going to have to make sure that multicast is enabled in the underlay. And there's another video in the channel that goes through multicast, and you can have a look at that to get a better understanding. But since we're just looking at kind of the configuration changes and how to enable IP-directed broadcast, we don't need to worry about that right now. So as soon as I say deploy here and apply, I'll give it a few seconds. While this is working, I can come back to my fabric infrastructure. I can wait for this to be completed. It'll take about 15 seconds or so. And once that's done, we'll go back and look at specifically the border. We'll have a look at the edge node just to see, if anything happens there, but we'll find out what that is in a minute. So if I look back at the border here and I go back and run the same command, remember it was show run interface loopback 200. Well, loopback 200 is gone, because as I mentioned in the slide portion, what we do is we replace the loopback with an SVI, right? Much like we had on the fabric edge. So here it is. Now it's interface VLAN 200. I've got the same IP address, the same helper address, everything on the border. However, what I've also got is IP-directed broadcast. And then remember I said there's this no auto state. Now what no auto state does is, again, it keeps the SVI up in case there are no physical ports that have that VLAN active on them. And remember, since this is a border and I'm not going to have user or device ports, most likely I'm not going to have any physical ports and any VLAN that would have IP-directed broadcast necessary on the border. So this no auto state is really important to keep the SVI active when there's no physical ports with that VLAN. If I close out of here and go to the edge node and run the same command, we can quickly see show run int VLAN 200. There's nothing changed here, right? We didn't add any commands. There's no IP-directed broadcast here. There's nothing else. This is exactly as it was before. So as I mentioned in the slide portion, the only thing that gets impacted is the border when we make this command, and obviously we do enable layer 2 flooding for that subnet as well. Now that was the example of a subnet where I already had something in place and I wanted to enable IP-directed broadcast on a subnet that didn't have it. Obviously, if I want to add another subnet here, and I'm going to say add, and I've got another one. Normally we don't put the guest subnet in with the corporate, but this is just an example, so we'll do that. I'll give that, let's say, VLAN 300, and I'll just give it a name of guest. Now here, if I say IP-directed broadcast, I also enable the layer 2 flooding automatically, just like we did when we did the update. I can give it a traffic of data. I don't need to give it anything else. I click add here and deploy and apply. So once again, we'll close this out. We'll go back to our fabric infrastructure. We'll give it a few seconds to complete. But what we should see on the border is that there's no loopback in the first place. It's just the SVI that's created. And then there should be a similar SVI on the edge node. So we'll close this out. We'll go to the border. We'll do a quick, again, command here. We'll say show run, whoops, if I spell correctly, show run int loopback 300. Hopefully there's nothing. There is nothing, right? So show run int VLAN 300. And there we go. We built that one from scratch as we added that in there. There's the Anycast gateway address. We'll verify that in a second. But again, IP-directed broadcast and no auto state. So now as I close this out, I can go to the edge node and I can run that same command, show run int VLAN, oops, VLAN, whoops, sorry for my typing, 300. There we go. And there it is, 172.16.5.1, which was the same helper address. I don't have the no auto state. We're expecting that we will have interfaces in this VLAN because this is an edge node. This is where devices and users connect, etc. So there you go. That is how to enable IP-directed broadcast. And just remember that you must have the layer 2 overlay in place, which it will put there for you, obviously, when you do that. But to support that layer 2 overlay, you must also have the multicast and the underlay. And again, you can find that information in another video in the channel. So thank you very much. I hope you had a great day. Don't forget to like us. And yeah, thanks.